What is autopilot? Can it be used during takeoff? Well, aircraft can be equipped with autopilot systems. Autopilot is a computerized system that automatically controls an aircraft's flight trajectory, altitude, and orientation, reducing the need for manual control by the pilot. Autopilot systems typically include 1. Flight Control Computer (FCC). 2. Sensors, accelerometers, gyroscopes, GPS. 3. Actuators, servos, motors. Autopilot modes. 1. Altitude hold maintains set altitude. 2. Heading mode maintains set direction. 3. Vertical navigation (VNAV) manages altitude changes. 4. Lateral navigation (LNAV) manages horizontal navigation. 5. Auto throttle adjusts engine power. 6. Autoland fully automated landing. Levels of autopilot automation. Level 0, no autopilot. Level 1, single axis autopilot, e.g., altitude hold. Level 2, two-axis autopilot, e.g., altitude and heading. Level 3, three-axis autopilot, full flight control. Benefits. 1. Reduced pilot workload. 2. Improved safety. 3. Enhanced precision. 4. Increased fuel efficiency. 5. Reduced pilot fatigue. Examples of autopilot systems. 1. Garmin G1000. 2. Honeywell Apex. 3. Rockwell Collins Pro Line. 4. Boeing 787 Dreamliner's Autopilot. Autopilot systems are widely used in 1. Commercial airliners. 2. Business jets. 3. General aviation aircraft. 4. Military aircraft. However, pilots must still monitor the aircraft's systems and be prepared to take control if needed. Now coming back to our doubt, autopilot usage during takeoff is limited but evolving. Traditional autopilot systems. 1. Typically not engaged during takeoff. 2. Pilots manually control the aircraft during takeoff. 3. Autopilot engagement usually occurs after reaching a safe altitude, example 1000 to 2000 feet. Reasons for limited autopilot use during takeoff. 1. Low altitude and airspeed. 2. Critical phase of flight requiring pilot attention. 3. Potential for automation-induced complacency. 4. Limited time for autopilot to react to unexpected events. Advanced autopilot systems. 1. Some modern commercial aircraft, e.g., Airbus A350, Boeing 787, feature advanced autopilot systems. 2. Autothrottle and autopilot engagement possible during takeoff, with pilot monitoring. 3. Enhanced automation for improved safety and reduced pilot workload. Autoland and auto takeoff systems. 1. Autoland. Fully automated landing systems. 2. Auto takeoff. Experimental, developmental systems for automated takeoff, e.g., NASA's Alhat program. General aviation and business aircraft. 1. Some autopilot systems, e.g., Garmin G1000, G3000, offer takeoff modes or autothrottle engagement. 2. Pilot monitoring and intervention still required. Future developments. 1. Increased automation in takeoff phases. 2. Integration with advanced flight control systems. 3. Enhanced safety features and pilot assistance. While autopilot usage during takeoff is currently limited, advancements in automation and safety features will continue to shape the future of aviation. For Module 11 lecture videos and question banks, contact on WhatsApp. Thank you. Like, comment, share and subscribe.